Hi everyone, we're solving this physics paper 5 today. This is 9702 paper 5-1 May June 2023 and the time is 1 hour 15 minutes. So before we get started, let's take a look at the threshold. Also guys, if you like the content, remember to subscribe to the channel and hit the like button. It really helps with the algorithm a lot. And remember to share the video with your friends if you found this helpful. Also with your juniors, you might need it in the future. And if you do require extra help, you can consider getting access to my Patreon. There are 3 tiers: one for general support, the other is for access to my solved question papers from 2002 to 2023 with working in OneNote for physics, chemistry, and bio paper 1, 2, 4, and 5, and math P1, P3, M1, and S1, as well as access to notes for AS and A2 physics and chemistry. You can also hand out requests for paper solving in my next YouTube video, as well as one-on-one problem solving sessions over text. And for the ultimate learning experience, you actually get all those features along with access to one-on-one video meetings with me where we solve your personal problems once or twice a month. So without further ado, let's begin. So let's take a look at this. This is component 5-1. Out of 30, A was at 23, so it was easier than 5-2. B was at 19, C was at 16, D was at 12, and E was at 9. Okay. So out of 30, A was at 23, B was at 19, 16, 12, and 9. D was at 12, and E was at 9. Okay, that's good, that's good. So A star should be at around 4 marks more than this, so that is pretty hard. 3 or 4 marks more than this, 26 or 27. So that is threshold. So let's start with the paper then, starting with question number 1. A wooden cube of mass A is placed on an inclined plane. The cube is attached to a cylinder of mass B using a string that passes over the pulley as shown. The angle between the plane and the horizontal surface is theta. Initially, the cylinder is held at rest. The cylinder is released. The time for the cylinder to follow distance d is t. It is suggested that t is related to theta by this relationship. Very complicated relationship, but doable, where h and k are constants. Plan a lab experiment to test the relationship between t and theta, and draw a diagram showing the arrangement of your equipment. Explain how these results could be used to determine values for h and k. So clearly, the relationship is between t and theta. So one is the independent variable while the other is the dependent variable. So how to figure this out? Always think of it chronologically. Think which value comes first. Would you set up the angle first or measure time first? Time to fall down. Clearly, the angle comes first, right? So since angle comes first chronologically, it is the independent variable, and since time comes later, it is the dependent variable. That is the main idea. Now, this is part of defining the problem. So now you have to talk about things that you need to keep constant. So let's talk about it. So clearly it can't be t and theta since these are variables, and also it can't be h, it can't be k since these are already constants which are mentioned in the question. So there's no point in mentioning something that's already written in the question, right? So now it's between 2 is a constant, it's between a and b, a and b over here, since it's in the equation. You could also consider other things that aren't mentioned here on the right hand side. Suppose d is also present on the left hand side, so we need to talk about all of them since we aren't sure. Okay, so ideally what we should write here is keep d constant, keep a constant, and keep b constant. Some of the points here will be part of additional details, and one of them will be part of defining the problem. And in this particular question, d was part of defining the problem. So that's what we write initially. After cutting out the things that are mentioned as constants, and after cutting out the variables, we end up with d, a, and b. So we're going to write keep d constant, keep a constant, and keep b constant. That's how it works, okay? So that is defining the problem. Now let's talk about methods of data collection. What do we need to find out? Basically, we need to find out the angle, which we can using a protractor, or we can actually talk about a ruler to find out specific lengths. Why? Because as you can see in our equation, we actually need sine theta. So we can actually find out sine theta using opposite by hypotenuse, which would give us an extra point. And for time, since it's a very fast moving object, right? We should use light gates connected to a data logger or a timer to measure t. The problem with using a stopwatch is, there's the percentage error actually increases. So yes, you could use a stopwatch, it's accepted in the mark scheme, but honestly using light gates connected to a timer is a much better option. All right, and for the diagram, as you can see, you just copy the same diagram, but it's flying, the system is flying, so you need a stand to support the plane. Okay, and you need to label everything. And what else do we need to measure? um what are A and H specifically? A and B, sorry, A and B, these are the masses of the cubes, so we can use a balance to measure the masses. And we need to measure D, which is the vertical distance the cylinder has to fall before it touches the ground, the table. So we can use that. You can measure that using a ruler, and that ruler needs to be clamped in the diagram. It needs to be supported, and to ensure that it's vertical, we can use a set square. So these are the basics. All right. I've talked about them already. So yeah, let's go for it. So the dark green part is actually part of defining the problem. So theta is the independent variable and t is the dependent variable, or you could just say that vary theta and measure t. And we need to keep d constant, keep a constant, keep b constant. So keep a and b constant. This is actually a part of additional details, and keep d constant. It's actually part of defining the problem. Now what else? We have to use a protractor to measure theta. That is one option, or you could opt for use a ruler to measure appropriate lengths for a trigonometric calculation. And then if you write down that sine theta, right, sine theta, the correct trigonometric calculation, is equal to opposite by hypotenuse. If you write that down, you get an additional point. Now if you use the protractor, yes, you can get another additional point, but for that you need to draw the protractor itself on the diagram, then you can get the additional detail. Okay, I feel like using trigonometry is a much easier way to get a mark. Okay, so that's that. Anyway, you need to remember that um, methods of data collection has 4 points, and usually one of them lies in the diagram. So we are using a protractor to measure theta, or a ruler to measure appropriate lengths to find out the trigonometric function. We are using a timer, stopwatch, or the one I prefer. You either use a timer or stopwatch to measure t, or you just write this. Use light gates connected to a timer to measure t. Any one, okay? I'm just writing both for you guys to learn properly. That's all basically. So what was this point? I can't undo it sadly. Use a timer, stopwatch. Use a timer or stopwatch to measure t. Or the alternate is use light gates connected to a timer to measure t. I prefer that. Okay. So the light green points are for methods of data collection. Okay. Ruler to measure appropriate lengths for trigonometric calculation, and sine theta part is actually additional detail. Use a timer or stopwatch to measure t, or light gates. Always remember, when you write light gates, you have to add connected to a timer with it. Okay. And we are going to measure d using a clamped vertical ruler, which we also show in the diagram. Okay, if you show it in the diagram, that is enough. So this is how it works. I just copied the diagram itself, and here you get the mark for labels and drawing the stand or a support for balancing, for balancing the you know um, the plane. Okay, now I've drawn the clamped vertical ruler on the right hand side, and I've also drawn light gates connected to a timer that actually measure the time taken for the cylinder to fall the distance d, as you can see. And I've labeled opposite and hypotenuse as well, that help us to find out theta. We are going to measure those lengths using a ruler as well. Okay, so this is everything, and you mainly need to label the cube, the cylinder, the angle theta, the plane, the horizontal surface, and the stand. Then you get the mark for the diagram. Okay, now let's move on to the next part. You can pause this and copy. So the ruler has to be clamped. Okay, and yeah, it has to have a stand next to it. Next, let's talk about additional details. So we've already written three additional details here. Like one of them was keep A and B constant, and we're going to use a balance to measure A and B. I already talked about that. And there is another mark for the trigonometric relation, right? So 3 marks over here. So although there are 10 points for additional details, you can score a maximum of 6 out of 10. Okay, we've already gotten 3 here. So what are the other ones? For example, the safety precaution might be, since there's a falling cylinder, what should the safety be? We should use a cushion or a sandbox to prevent any injuries when it falls, right? And what else? Repetition, right? We have to repeat the experiment. We have to repeat the experiment or repeat measurements of t using the same value of theta, right? You repeat measurements of t for same value of theta to get an average value of t. That's the basic idea. So using the same value of the independent variable theta, for example using 30 degrees, you're going to repeat the experiment multiple times to get multiple values of t, and then average to get an average value of t, an average value of the dependent variable. Okay, that is the logic. All right, so yeah, let's move on. And there are other points which we will talk about. So use a cushion or a sandbox to collect the cylinder or prevent damage to cylinder. So you have to talk about using a cushion or a sandbox. Why? To collect the cylinder, that is one option, or to say to prevent damage to the cylinder, floor, or bench, or to prevent injuries. That's what I prefer. And repeat measurements of t for the same value of theta and average t. So for all experiments that should work, this is the pro forma. Repeat measurements of the dependent variable for the same independent variable and average the dependent variable. Okay, now to that increases reliability. Okay, now to increase the accuracy, to reduce the percentage error, what we can do, we can use larger values of d. So for example, if you release the cylinder from a higher height, the value of d will actually increase. Okay, the value of d will actually increase. Rather than 1 meter, maybe 2 or 3 meters, and as a result the cylinder will take a longer time to fall down, and which will ultimately reduce percentage error. Okay, so we are going to use a larger value of the constant value of d to increase the value of t, which actually reduces percentage error. There were some other obscure points that you know was unlikely that you think of in the exam hall, because we already got full marks by writing these three, then the cushion, repetition, large values of d. These are some other points that are also included in the mark scheme. Method to release the cube. Okay, so the cube should be held using a set square, or the set square should be moved to release the cube. What does that mean? For example, it's gonna fall down, right? We can hold it using a set square like this. We can hold the cube using a set square, then we can just move it. If we move the set square, what will happen? The cube will move to the right and the cylinder will fall down. So that's what they're saying. We have to use a method to release the cube rather than apply a force. Rather than applying a force, we have to hold it in place, and then when we move the set square, it will fall down. The cube should be held using a set square, and the set square should be moved to release the cube. And finally, there's another obscure point that is very unlikely that you think of in the exam hall. Adjust the length of the string to keep d constant as theta changes. But this is very important. What does this mean? What does this mean? As you keep on increasing theta, what's going to happen? The you know the slope is going to be steeper, right? So if you keep it in the same spot, right? Suppose if you keep the cube in the same spot, what will happen? Since the slope is becoming steeper, the cylinder will move to a higher height, and what will happen? Maybe this distance will change to 2 meters, but we just mentioned in the first part, d needs to be kept constant. So how are you going to do that? Mainly by doing this, we are going to adjust the position of the cube. We're going to move it further up over here so that this distance always remains 1 meter. That's what this last point means. Adjust the position of the cube, right? To change the length of the string. Adjust the length of the string to keep d constant as theta changes. Very important point, but rather obscure. Like, it's hard to think of this in the exam hall. Okay, that's that. Finally, let's move on to analysis. One more thing. There are two more additional details. One I'll talk about later. The other one is the positioning of the light gates to determine t. So I've drawn them in the diagram, right? Two light gates either end of distance d and connected to a timer. You need to mention that. The two light gates should be at either ends of D. You can write it in text or show it in the diagram, and they should be connected to timers, okay? Or you could use a video camera with a timer in frame of the video to determine T, slow motion, right? So the wording for that should be the video, correct position of video camera with timer in frame of the video to determine T. One should be at the beginning and one should be at the end, right? Or we could, just use one camera to record the whole thing, the time it takes to fall down. But I honestly prefer light gates, right? One at either end of D and connect it to timers. That will give us the reading perfectly, okay? Now let's finally move on to analysis. So what's our end goal over here? Since t is the dependent variable, it should be on the left hand side, right? So it's 2d by t square is equal to minus ah sine theta by a plus b minus ka by a plus b. So basically what we need to do is only t should be on the left hand side. I'm moving everything else to the right hand side. So 1 by t square is equal to minus ah divided by a plus b times 2d times sine theta. I'm separating sine theta because it is the independent variable. Minus ka divided by a plus b into 2d. So what do we have finally? For the analysis, it should be like this. Plot a graph of 1 by t square against sine theta. The dependent variable against the independent variable. And since there's a sign here, I include that as well. So plot a graph of 1 by t square against sine theta. The relationship is valid if a straight line is produced that does not pass through the origin due to the presence of this y-intercept, okay? And yeah, we need to say how to find out the values of h and k. Now, this point, the relationship is valid if a straight line is produced that does not pass through the origin. This is actually part of additional details here. Why? Because there are two constants that they told you to find out. If there are two, each one actually holds one mark, so the point relationship is valid if a straight line is obtained that does not pass through the origin or passes through the origin. Actually accounts for another additional detail. This will only be valid when there are two constants that they tell you to find out, okay? Does that make sense? So here you go. This is the analysis. So I did the analysis on the left hand side over there. So plot a graph of 1 by t square against sine theta. The relationship is valid if a straight line is produced not passing through the origin. It's orange because it's an additional detail. You can only write 6 out of 10. If you write more, there's no problem, but you won't get extra marks. And to find out h and k, what can we do? Minus h by a plus b times 2d is the gradient. So h is actually equal to minus gradient times a plus b times 2d by a, while k is actually equal to minus ka by a plus b times 2d is the y-intercept. So k is equal to y-intercept times a plus b times 2d divided by a. So that is it for question 1. You can pause the video if you need to copy anything from here. And here's the other part of the question. So yeah, small questions, not that complicated, very typical. The analysis part was a bit, it was bigger compared to usual. So let's move on to question 2 then. A student investigates the discharge of capacitors in the circuit shown in figure 2.1. The capacitors have capacitances Cp and Cq. They are connected in series. Okay, fine. Now the student closes the switch to charge the capacitors. Fine, okay, and then records the maximum voltage reading on the voltmeter. Then the switch is opened and a stopwatch is started. The capacitors discharge through the resistor. The reading on the voltmeter decreases. When the reading on the voltmeter is V, the time t is recorded. Discharge of the capacitors is repeated and the mean time t is calculated. The experiment is repeated for different values of Cp and Cq. For each combination of Cp and Cq, the combined capacitance is calculated. It is suggested that C and T are related by the equation ln V by V naught is equal to minus T by Cr. Our graph is where R is the resistance, obviously. Now, a graph is plotted of T on the y-axis against C on the x-axis. All right. So we need to put T on the left-hand side. So let's try to solve this. So ln V by V naught is equal to minus T by Cr. So T is equal to minus ln V by V naught times RC or CR. And then finally, we need to separate C since C is the independent variable. It's on the x-axis. So T is equal to minus ln V by V naught times R times C, where minus ln V by V naught times R is the gradient. Okay, that is all, and it has no y-intercept. That's good. So that was the first part. Now we are asked to fill up this table. So capital C, what is it? Capital C is the combined capacitance. So since they are in series, what is the formula? 1 by Cp plus 1 by Cq and reciprocal to the power minus 1. That should be the formula. I'll show you how it's done. For example, 1 by 2.2 plus 1 divided by 1.5 reciprocal. Do this in the calculator. What do you get? 1 by 2.2 plus 1 by 1.5 to the power minus 1, that is 0.89189. Now, since the data is in 2SF, you have the option to give the answer. This is in 2SF, so you have the option to give the answer to 2SF or 3SF. So you can either write it as, 0.89, or you can write it as 0.892. So either 2SF or 3SF since the data is given to 2SF. All right. So that's that. You repeat the process for all the other ones. 1 by 5.6 plus 1 by 3.3 reciprocal. You get the answers. I opted for the 2SF answers because it's easier to plot the data. Next, for T, we are asked to find out the mean or the average. It's pretty straightforward. You know the drill is going to be 12.9 plus 14.5 by 2. Let's try that. 12.9 plus 14.5 divided by 2, that is 13.7. Okay, 13.7. Data 3SF, so answers to 3SF or 4SF. 3SF here because all of them, for all of them we do get 3SF answers. And for the uncertainty in any average, okay, for example, if we have to average the value of three things, 2, 2, 4, and 6, do the average. It's going to be 2 plus 4 plus 6 divided by 3, right? 2 plus 4 plus 6 by 3 is equal to 4. And for the uncertainty in this value, it's always going to be the highest value minus least value by 2. So 6 minus 2 by 2, that is the range by 2. So that is 4 by 2, which is plus minus 2. That is always the formula for uncertainty for anything that you average. So for here, what is the highest value? 14.5, and least value is 12.9. So 14.5 minus 12.9 divided by 2 actually gives you a value of, check it out, 14.5 minus 12.9 by 2, that is 0.8. That is the uncertainty, the first value. And yeah, you can repeat it for the others. For example, the last one is 32.1 minus 30.9 divided by 2, that is 0.6. So just like that, all of those can be figured out. You can match it with the table. You can solve it, pause it, and match. Then let's move on to the plotting. I'll just give you one sec. Now let's move on to the diagram. So you can plot the graph using these values. It's actually a graph of what exactly? What was it? T against C, T against C, T against C, here you go, T against C. There you go. Now, for example, and t is on the y-axis, right? So the error bar should be vertical. So I'll show you the first one. For example, it's 0.89 against, sorry, 13.7 against 0.89. So 0.89 over here, right? So this is 0.8, this is 0.9, this is 1. So 0.82, 0.84, 0.86, 0.88. 0.89 should be in between 0.88 and 0.9. And 13.7, right? This is 12, 13, 14. This is 13. So 13.2, 13.4, 13.6, 13.8. 13.7 is in the middle of 13.6 and 13.8. So that's the first point. Here you go, guys. If you want to see the points, this is how it's done. Okay, 0.89, 13.7, then 1.3, 20.4, 1.3, 20.4. Oh, it's arranged haphazardly, my bad. So the next one is actually 1, 16.1, 1, 16.1 over here. Then you have 1.2, 18.3. At 1.2, you have 18.3, 1.5 boxes after 18. Then for 1.2, 1.3 we have 20.4. 1.3 is in between 1.2 and 1.4. For 1.3 we have 20.4. That is like 2 boxes above 20. Then for 1.6 we have 24.3. 1.6, 24.3, 1.5 boxes above 24. Then 2.1 we have 31.5. 2.1 in between 2 and 2.2. We have 31.5, which is in between 31 and 32. Yeah. And for the error bars, this is how it's done. For example, take a look at the first point, 13.7 plus minus 0.8. So 0.8 means 4 boxes, 4 small boxes. So 1, 2, 3, 4. 1, 2, 3, 4, like that. I'll show you a better point. For example, the one at 1.3, right? So 1.3, it's 20.4 plus minus 0.7. So 20.4 plus minus 0.7, that means 3.5 boxes. This is 1, 2, 3, 3.5, 1, 2, 3, 3.5. That's how you do it, okay? All of these will be vertical. You can match with me. I'll just zoom in for you guys. It should be something like this, okay? Now I've drawn the line of best fit and the worst acceptable line, and I've also labeled them. How is it done? You know how to draw the line of best fit, right? It just has to be balanced, yeah? So for example, the way I did it was I made it go above the first point, below the second, then below, above the third, below the fourth, and it passes through the fifth and sixth points. Okay, so above first, below second, above third, below fourth. There's a balance, 2 points above, 2 points below, and passes through the other two. Okay. And for the worst acceptable line, you can either draw the shallowest line or the steepest line. I actually opted for the shallowest line. So make it go through the lower bound of the highest point on the right and the upper bound of the smallest point on the left hand side. And as you can see, it passes through all the error bars, so we don't have to do any editing. Okay, this is how it's done. Passes through the upper bound of the smallest point and the lower bound of the highest point on the right. Okay, pretty straightforward. And yet if you want to check your graph, okay, this is how you can check. So according to them, the line of best fit should pass through 1.42 22 and 1.45 22. So this is 1.5. So 1.42 22, 1.42 22, and 1.5 22, 1.45 22, sorry. 1.42 and 1.45 at 22. Yes, it passes through it. And on the other hand, 1.95 30. 1.95, that is over here, between 1.9 and 2. 1.95 at 30 over here, and 2 at 30. Yes, my line of best fit passes through it, although it should have been a bit more on the left hand side. Like something like this would have been better, maybe something like this. Yeah, something like this, but it's fine. I am happy with my line of best fit, very happy, because there I struck a balance, right? in the points above and below the lines. Then I draw a dotted triangle which needs to cover at least 50% of the graph. You can use the crosses that your line of base passes through. Also, only draw crosses or dots, no blobs, okay? I actually prefer crosses, small crosses, yeah? Now, as you can see, I've written the points for the line of base fit and the power, I've included that as well. So, for the line of base fit, it's at 1.08 into 10 power minus 4 and at 16.8 on the y-axis, and the worst acceptable line is like this. Similarly, I've also taken the point up here. I always use one dotted triangle that works for both lines. That way, you know, there's less work but most efficiency. That's how we got these points. One is at 31, the other is at 30.44 worst acceptable. Then I find out the value of the gradient, once for the best fit line and once for the worst acceptable line. And then we just simply subtract the gradients to find out the value of the uncertainty. So you can give the value of the gradient to 2 or 3 SF. I opted for a 3 significant figure answer, which is 145,000, 145,000, and the uncertainty I rounded off to 9,000 from 8897. So that's 145k plus minus 9,000, and ensure that you include the power from the from the x-axis over here, okay, or else your answer won't match with me. So the value of your gradient will not exactly match with mine, but it will be along the lines of this, okay? Next, moving on. So next, we are asked to do this math. So let's do this. Calculate ln v by v naught and include the absolute uncertainty. So ln v by v naught, it's 2.4 by 4.8. Fine. That gives you a value of 0.69. Now the data is given to 2SF. For ln, the rule is a bit different. If data is given to 2SF, you have to give your answer to 2dp or 3dp. 2SF data results in an answer that is at 2dp or 3dp. That's the logic. 2dp or 3dp due to 2SF. So you can either write minus 0.69 or minus 0.693. Any of these two. And about the uncertainty, this is a bit complicated. Okay, let's go through this. So for ln, what's the typical rule? It's ln upper bound minus ln lower bound divided by 2. That's the general rule. Okay. Now, what is the upper bound here essentially? What is the upper bound? So ln v by v naught is basically, if you think of the upper bound, the value of v naught varies from 4.7 to 4.9 and the value of v varies from 2.3 to 2.5. Now, if you want the upper bound, what do you need to do? You need to take a big numerator and a small denominator. That's why I chose 2.5 on top and 4.7 below. That gives me the highest possible value of ln v by v naught. And the lower bound, we do the opposite. We take a low numerator, which is 2.3, and a high denominator, which is 4.9. So we get a value of minus 0.7563. That is the basic idea. So we have our upper bound and lower bound. Now we subtract them. So minus 0.63127 upper bound minus the lower bound minus 0.7563 divided by 2, which gives us an answer of plus minus 0.0625. So that is just 0.06. So that is our uncertainty. I have never seen this before, by the way, maybe just once, but this was very hard for the average student and for better students as well. So yeah, be careful about this. But the general idea is upper bound, highest value, minus ln lowest value divided by 2. That's the logic. Next, using your answers to A, C, 3, and D, find out the value of R. So you gotta use your main equation, which is T is equal to minus ln V by V naught R times C. So I just put that in over here, and we know that minus ln v by v naught r is the gradient, so r is equal to the gradient divided by minus ln v by v naught. So my gradient is minus 145, it's 145k, so minus 145k divided by minus 0.69 gives me an answer of 210000. And they want a unit for r, so r is resistance, so you can just go for ohms. And I can teach you the other trick. It is basically second by farads. That's the unit for the gradient. So the unit for the gradient is actually seconds by farad, or SF to the power minus 1. Now what is farads? We know that Q is equal to CV, C is equal to Q by V. So second by farad is actually, you know, what is Q? Q is equal to IT, which is ampere second, divided by voltage, which is volts. So you can actually get rid of the seconds over here, and after reciprocal you get volts by amperes, which is basically ohms. Okay, so either write down V by A or ohms. Ohms is the best answer actually here. Okay, so that is 2.1 times 10 to the power 5 ohms for me. Now determine the percentage uncertainty of R. What does R depend on? The gradient as well as ln V by V naught. So percentage uncertainty of R will be del gradient by gradient plus del ln V by V naught by ln V by V naught times 100%. So for my values, it's 9000 from the gradient by 145k plus 0.06 divided by 0.69 times 100%. It gives me a value of 15%. You can check the working. Please do tell me if I have any mistakes in the comment section. And finally, the experiment is finally repeated again, and determine the value of C that gives a value of t of 60 seconds. Include the absolute uncertainty in your answer. Fine. So we know that t is equal to minus ln V by V naught R times C, and minus ln V by V naught R is the gradient itself. So I can just input 145k in the place of minus ln V by V naught R. Don't be a rookie and include the minus sign. The minus will disappear when you input the gradient. Okay, that's the important part over here. Okay, and t should be 60. So if you find out C is actually 60 by 145k, which is 4.14 times 10 to the power minus 4 for me. I opted for a 3SF answer. They want us to include the absolute uncertainty for C, so that should be, it only depends on gradient, right? And T has no uncertainty, so del C by C equals to del gradient by gradient, and del C is equal to 9k by 145k times your calculator answer, which gives me a value of 2.56 into 10 power minus 5. I adjusted it according to the power, so that's 0.256 times 10 to the power minus 4 farads. So that's 4.14 plus minus 0.26 into 10 power minus 4. So your answer should be along the lines of these, but not exactly this, okay? Because our values may vary. So yeah, that has been it. This is the working. Like if you want to input ln V by V naught and R separately, all right? So that has been it for the paper. Pretty straightforward paper, I think, which is why it has a higher threshold compared to paper 5.2. Do comment below if you have any other problems or any other requests. I'll try to solve that. I hope this paper was helpful for you. Quick shout out to my top tier patrons for the month. For this month, we have Dewa as usual and a new patron, Prabha. So if you want to be featured at the end screen for my videos, please consider supporting me on Patreon on the highest tier, where you get access to all my notes as well as video meetings with me where we can solve your personal problems over Google Meets, right? Anyway, I will link the paper for May-June 2023, paper 5.2 up here, and the paper for October-November 2023, paper 5.1 down here, and the playlist for Physics P5 up top. And remember to hit the subscribe button. See ya guys, bye bye.